Okay, Wildcat, so we're 1.3, modeling situations with exponential functions. Simone is studying for a big test and is trying to stay awake. He drank a 12-ounce can of Big Buzz energy drink that contains 80 milligrams of caffeine. He is wondering how long the caffeine will stay in his system if the caffeine has half-life of 5 hours. A half-life is the amount of time it takes a substance to decay to half of its original amount. 1. How much caffeine remains in Simone's system after 5 hours? After 5 hours, 40 milligrams of caffeine are left in Simone's system because it takes 5 hours to cut the amount of caffeine in half. Two. Complete the table to determine the amount of caffeine in Simone's system at each time interval. 3. What is the initial amount of caffeine in Simone's system? What is the rate of decay? The initial amount of caffeine is 80 milligrams. The rate of decay is 1/2 for every 5 hours. Let's take a look at the next page. 4. Emily was asked to write an exponential function, a of t, to represent the amount of caffeine remaining in Simone's system after t hours. Emily, a of t equals 80 times parentheses 1/2 to the t divided by 5. The variable represents the number of hours and the half-life occurs in 5-hour cycles, so I divided my exponent by 5. Go ahead and mark out Tyler, Renee in A and B. 5. How much caffeine remains in Simone's system after 2 hours? So what we need to do is plug 2 into the equation. So let's go ahead and do that. So that's 80 parentheses . Okay, so let's round that to 1 decimal place, so that's 61 milligrams. So there are 61 milligrams of caffeine in Simone's system after 2 hours. All right, let's take a look at the next page. 7. Use technology to predict when the caffeine will be completely out of Simone's system. Does this make sense, given that you know about exponential functions? Explain the reasoning. So let's go ahead and take a look at the function. Let's change the 2 to an x. And then we want to write that as a of x equals. Let's go ahead and zoom out. Now you can see the caffeine is decreasing, and it's decreasing, but when you come in and zoom in, it looks like it hits 0, but it gets very close, but it never touches 0. So because of that, the caffeine will never be completely out of Simone's system because the amount will be divided in half until there is just a trace amount left. 8. Approximately when will the amount of caffeine remaining in Simone's system be less than 1 milligram? By graphing y equals 1 and a of x equals 80 parentheses 1/2 raised to the x divided by 5. Okay, so let's press the home screen. Zoom out just a little bit so we can see the graph. I'm going to graph, we already have this function graph. Let's graph y equals 1. Now, at 31.6, which let's round that to 32, is when it's equal to 1. So after that is when it'll be less than 1. So the amount of caffeine remaining in Simone's system will be less than 1 milligram after 32 hours. Okay. Go ahead and mark out 9, 10, and 11. Go ahead and mark out this page. The student works 1, 2A, 2B, and 2C. Go ahead and mark out this page. And then go ahead and mark out this page. All right, go ahead and finish up your notes, start working on the assignment, and have a wonderful Wildcat day.